The Latin word nebula, which means cloud, is used to describe any celestial object that, when viewed through a telescope, appears to like a cloud. This name included galaxies like our neighbor Andromeda, sometimes known as the Andromeda Nebula, when telescopes weren't as advanced as they are now. However, we now know that galaxies are made up of billions of stars instead of clouds, thanks to the use of modern telescopes. As a result, astronomers only use the term nebula to refer to actual clouds of gas and dust that are found within our own galaxy. The interstellar medium, the area between stars, is where nebulae are frequently seen. Only about 1 atom is present in this area every cubic centimeter on average. The density, however, can be much higher than this in some areas, high enough to be visible through a telescope. Nebulas, which are among the most breathtaking views in astronomy, are what we term the product of this process. Nebulae are really depicted in a large number of the most famous Hubble telescope photographs, including the pillars of creation. Nebula can be classified into a number of various categories according to how they form and what they are made of. Most nebulae are mostly composed of gas, which has the ability to glow with its own light, producing the vivid displays we are accustomed to. The so-called black nebula is one example of a nebula that is more dustier in composition than others. Rather than shining, this dust has the effect of obstructing light from farther away things beyond it. Both at the beginning and end of a star's life cycle, nebulae are important. Diffuse emission nebulae, commonly referred to as stellar nurseries, are where stars are created in dense clusters of gas, dust, and other matter. This includes the renowned Orion Nebula, which you may have already viewed with binoculars or a small telescope, as well as Hubble's pillars of creation. Gravity, which causes the flimsy interstellar medium to condense into a nebula, and gravity, which causes clusters within the nebula to collapse down into stars, are the main forces at play in this situation. A different kind of emission nebula is found near the conclusion of a star's existence. White dwarf stars, like the Sun, are the most dense form of star at the end of their lives, but as they transition into this state, gas is released, creating what is known as a planetary nebula. Due to the fact that such nebulae have nothing to do with planets, the moniker is somewhat misleading. These nebulae are more distinct than diffuse emission nebula, typically having a circular form that, when William Herschel first saw them in the 1780s, made him think of a planet. Not all stars pass away amid the comparatively calm of a planetary nebula. Supernova remnants are still another type of nebula that are created when a star that is far more massive than the Sun finally explodes as a supernova. The Crab Nebula, which is all that's left of a stunning supernova that Chinese astronomers saw in 1054, is the most well-known of these. Telescopes like the Hubble Space Telescope and the James Webb Space Telescope, JWST, utilize infrared light released by nebulae to make images that depict the amazing nature of nebulae. The vast cosmic clouds of gas and dust that make up a nebula can obstruct the visible light emitted by stars forming in and around it. As a result, researchers must focus on other light wavelengths that are emitted from the nebula, like infrared radiation. The Southern Ring Planetary Nebula and other nebulae have been captured in some of the most intricate detail by infrared cameras on board the JWST. Around 2,500 light-years away from Earth, the Southern Ring Nebula, commonly known as NGC 3132, contains a dying star at its center. The JWST has produced one of the nebula's most intricate images using its near-infrared camera, NIRCam, and mid-infrared instrument, MIRI. The Southern Ring Nebula's layers of gas and dust are visible in the two photos above thanks to JWST. Each layer was produced by the cosmic matter that was ejected from the central dying star. Other nebulae are created by supernova explosions, which are the latter stages of the lives of huge, short-lived stars. The energy and compact object that the supernova center generates then ionize the materials that were released during the explosion. The Crab Nebula in Taurus is one of the greatest instances of this. The supernova event is known as SN 1054 and was noted in the year 1054. The neutron star in the center of the compact object that resulted from the explosion is located in the Crab Nebula. The majority of nebulae are what are known as diffuse nebulae, which are expansive and lack clearly defined borders. Emission nebulae, reflection nebulae, and dark nebulae are the three categories of diffuse nebulae. The two types of visible light nebulae are emission nebulae, also known as H2 regions, which produce spectral line radiation from excited or ionized gas, mainly ionized hydrogen, and reflection nebulae, which are visible mostly because of the light they reflect. Reflection nebulae are close to stars and reflect light from them, but they do not produce much visible light on their own. They are known as dark nebulae. Comparable nebulae that are not lighted by stars do not produce visible radiation, but they can be found as opaque clouds that obscure light from illuminating objects behind them. Although the optical visibility of these nebulae varies, they are all prominent sources of infrared emission, primarily due to dust within the nebulae. Planetary nebulae are the remains of mid-mass stars, which range in size from 0.5 to 8 solar masses at the end of their stellar life. Strong stellar winds cause evolved asymptotic giant branch stars to shed their outer layers, generating gaseous shells and leaving the star's core behind in the form of a white dwarf. Expelled gases are excited by radiation from the hot white dwarf, creating emission nebulae with spectra resembling those of emission nebulae found in star formation zones. Since most of the hydrogen in them has been ionized, they are H2 regions, yet planetary nebulae are denser and more compact than nebulae seen in star formation regions. The first astronomers who saw them were initially unable to tell them apart from planets and tended to confuse them with planets, which were of greater importance to them, giving them their name. A planetary nebula is predicted to form 12 billion years after the birth of our Sun. An astronomical object known as a protoplanetary nebula, PPN, is a brief period in a star's rapid stellar evolution that occurs between the late asymptotic giant branch, LAGB, phase and the planetary nebula, PN, phase. The star loses mass during the AGB phase and emits a hydrogen gas disk around itself. The star moves into the PPN phase at the conclusion of this phase. The center star energizes the PPN, causing it to generate powerful infrared radiation and develop into a reflection nebula. The shell is shaped and shocked into an axially symmetric structure by collimated stellar winds from the core star, which also create a swiftly flowing molecular wind. The temperature of the central star determines the precise point at which a PPN transforms into a planetary nebula, PN. The PPN phase lasts until the core star is hot enough to ionize the surrounding gas, which happens when its temperature hits 30,000 K. When a high-mass star reaches the end of its lifespan, a supernova happens. The star collapses after nuclear fusion in its core is stopped. The star explodes as the gas going inward either bounces back or becomes so intensely heated that it spreads outwards from the core. A peculiar diffuse nebula called a supernova remnant is created by the gas shell's expansion. Although ionized gas is largely responsible for the optical and X-ray emission from supernova remnants, a significant portion of the radio emission is a type of non-thermal radiation known as synchrotron emission. High-speed electrons oscillating in magnetic fields produce this emission. That was for today. Thank you for staying with us. Don't forget to like our video and subscribe to our channel.